So, as you know that today's session is about utilizing of machine learning, especially in the field of aerospace engineering. So here today you're going to learn about how to work on this machine learning using MATLAB or Python, and if you have a data set, so what are the futuristic work you can do? As you know, any design requires kind of training data and some sets of data. How you can work on those datas, or basically working on the existing work and modifying those things or data, and you can make a better one. So today we have Dr. Arunava sir. So he's going to give you an hands-on experience on that how you can utilize work one of the very typical type on machine learning, which is non-linear regression model, right? So over to you, sir.
Okay, good evening all. So today, basically, in case of aerospace engineering, some data sets are there. We are in general in aerospace engineering. We are generally in case of aerospace design, we design the optimal design of an aircraft. Okay, so there are many types of aircrafts are present there. So the optimal design means so we have to target something. Either we need to maybe for if we are talking about the sustainability or fuel consumption. Okay, so how to design an aircraft so that the fuel consumption will be minimum. Okay, so based on that, we need to make a model, okay, to design an optimal aircraft design so that the fuel consumption of that particular aircraft will be minimized. Similarly, there are many other parameters to design a aircraft are represent there. Somebody also may have the targeted to means optimize or maximize the range of the aircraft or maximize the speed of the aircraft. Okay, so different parameters, so we need to target some particular parameter which we are going to optimize basically. Okay, whether we are going to optimize the fuel consumption, that is minimize the fuel consumption, or maximize the speed, or maximize the range. Okay, or there are many other parameters present in aircraft. So in that case, we need to design that aircraft based on some data set first. That is, we need to make a model, that is how different parameters are interrelated or having the relation between each other. Okay, and to establish the relation between different parameters of an aircraft, we need the machine learning. Basically, there are two types of machine learning. One is called supervised, another one is called unsupervised. Okay, so basically regression, okay, and classification as there. Regression are basically supervised machine learning under the category of supervised machine learning. Okay, and we will basically talk about the regression here. Okay, I'm very much specific because all of you are not from the background of data science or machine learning. So I have to be very much specific that what your need is, and what is the requirement to make the proper aircraft model. So that is why I need to be very much specific for that kind of model only, which is where we need the machine learning algorithms. So let me first share my screen. Okay, please confirm the screen is visible or not. You can write down in the chat box, or you can unmute yourself and you can confirm whether the screen is visible. Okay, so okay, visible. So let me start with the analysis first. So basically, in case of based on the data set, since we are talking about the regression only, okay. So basically, classification and regression, there are two types of things are present, okay, and it is basically based on the data set. So what you are targeting, okay, optimal means targeting. Let us suppose a data set is like this. I am just giving you the example of such kind of data set. Every data set has different types of parameters, okay. So parameters like this, x, y, z, w. Let us suppose I am considering only four variables here, okay. So four variables, x, let us suppose it is, um, this is a medical data set. I'm just giving you an example. X is a, suppose it is BP, blood pressure. Y, it denotes the cholesterol, blood cholesterol. Okay, I'm just giving, not giving the short form, not the entire full name I am writing here. Z is, suppose it is the weight, and W, this is the target or outcome variable, and this variable, let us suppose it is representing whether obesity, okay. Okay, so based on this data set, now if we collect, now these are the different parameters. So our target variable, this is our target, that is the W is the outcome variable, which basically this is the outcome, and this W variable is based on or dependent on X, Y, and Z. So basically the outcome variable is dependent. X, Y, and Z must be independent to each other. Okay, so X, Y, and Z, there one thing you must remember, that no relation should exist between X, Y, Y, Z, or X, Z. No relation. The means these variables should be, there are independent, totally independent to each other. Okay, and now we have collected different patients. So this is patient 1, patient 2, patient 3, and so on. Let us suppose p 500 patients data are there, and it is suppose BP. Now there are two types of BP, systolic and diastolic. Let us suppose only the systolic pressure I am counting here. It is 80, 70, 90, and so on. Cholesterol, it is, let us suppose, I don't know basically actually what is the range of cholesterol. Just I'm writing here, let us suppose it is 50, 60, 70, and so on. Weight, um, suppose it is 60 kg. It is 70, 60, so it is, let us suppose, 55, and it is 82, and so on. Now the target variable obesity. Now this obesity, the target variable, we must write here yes or no, whether it is obese or not. The patient 1, let us suppose it is no, this is no, this is yes, and so on. So we have to target. Now what is our target variable? Our target variable is W, obesity. So look at the type of the variable. The type of the variable is binary here. Okay, only yes no, that is only 0 and 1 type of outcomes are there. So this type of problem is called classification problem. Classification problem, this is a type of machine learning problem where the data set is the target data set, that is the target variable or outcome variable is categorical. So this is only yes or no are there, so that is why we are saying it is a binary. Okay, if it is a suppose some car model we are going to identify, there are 3 or 4 types of car models are given here as output variable, then the category 3 or 4 categories will be there. So the data set, the outcome data set, it is called categorical data. Categorical data. And how many categories are there? The category number of categories 2. So this problem is called classification problem. And the classification algorithms are different types of algorithms are there. Okay, in machine learning, artificial neural network, ANN. Okay, random forest, classifier, decision tree. Basically decision tree, first decision tree is so decision tree, classifier, random forest, ANN, all these actually decision tree, random forest and ANN, these also are used for the regression also. Okay, but so that is why we are saying that random forest classifier, decision tree classifier. Okay, because this is a classification problem. And similarly, there are SVM, support vector machine. So there are different types of uh, machine learning algorithms present in the market. So you can choose anyone and you can, so the classification, there are some error analysis are there. Whether your model, what you have predicted, that model actually working good or not. Okay, so to check that one, there is different types of metrics. Metrics are present. One is called matrix, a matrix which is called the confusion matrix. Confusion matrix, which basically says that whether how much perfect your model is. Okay, and it is the prediction means your model, whatever the model you have done, and you have put some input in your model, and you need to there should be some target, that is output variable data. So how much it is it matches with the original data, based on that the confusion matrix it creates. Okay, so I'm not going for the confusion matrix, but I'm just going to show you that what is a classification and what is regression. So this is classification where the outcome data is categorical. Okay, now another type of data which is basically generally used in the aerospace, or to design optimal design of the aerospace, continuous data. Okay, so what type of continuous data is there? Let us suppose I am the same example I am giving here. Okay, and the outcome data here, the BP, cholesterol, and weight, they are acting as a independent variable. But dependent variable I'm using here, or target variable, dependent variable W. Let us suppose it is W1 and it is W2. It is as a mm, BP, cholesterol, weight. It is suppose it is um, sugar level. So blood sugar level, of course, it is. We cannot say it is yes or no. Yes, if it is the categorical data or target data is it is acted like this, whether it is the patient is sugar patient or not. then it is yes or no. But if I write here sugar level, okay, so sugar level means we need to specify the particular level of the sugar. So let us suppose it is 120, it is 95, it is 140, and so on. So look at the difference between this outcome data set and this outcome data set. So this outcome data set, it is categorical, only yes or no it exists, but this is a non-categorical where different number exists. And these numbers we cannot basically predict that here we can predict that either the outcome should be yes or the outcome should be no. But here in this case we cannot predict that what number it may. Okay, so it has a range which so this kind of data is called continuous data. So in continuous data we have to apply regression. Okay, so we have to apply here regression. Okay, so there are two data sets. So based on it is basically whether you have to apply classification or you will apply regression. It will be based on the type of data set. If it is categorical data like yes no, or some three or four types of car model or a aircraft model is there as an outcome variable. Okay, so that is called categorical data. For categorical data you have to use the classification algorithms. And if the target data, there is the outcome variable, is continuous like the sugar level 120, 95, what like this, then you need to use regression. Okay, if anybody has any doubt or question, then you can ask me now up to this point. So I request everyone, please be responsive, and so that it will be an interactive session. You can please write down in the chat box if you're having any uh, means type of queries up to this point, means up to regression and classification. Are you having any doubt? Okay, then I'm going for the next part. Okay, how regression yeah, you can use the regression. And first of all, let me introduce what is estimation. So far we have discussed about the classification or regression, and for which type of data set you are using classification, and for which type of data set you are using the regression. Okay, so now how to estimate, I will explain how to estimate this. So let us consider another data set. Okay, for this, and I am using very simple data set. So let us consider x, it is a marks of maths, y is a marks of stat. Okay, and z is the marks of let us suppose it is ml, machine learning. This is output or target. Okay, z is the output variable. So z must depend on x and y, but remember x and y they are independent. X and y they do not depend on each other. Their marks should be independent. Okay, so now I am collecting the marks of different students: student 1, student 2, student 3, student 4, student 5, student 6, and so on. Okay, and it is 10, 10, 9. 8, 7, 9, 0, 1, 2, 10, 9, 8, 5, 5, 4, 6, 7, 6, and so on. The total marks is, let us suppose, 10 full marks. 10 is the full marks of the exam, and this is the data set. Okay, now what is estimation? Let us suppose an unknown student. There is a student S uh, 10. The 10th student, we only have the marks of mathematics as 5, the marks of statistics as let us suppose it is 7. Then what should be the marks of the ML, that is machine learning? This is called estimation. Now you need to estimate. Now you have to look that this combination 5 and 7 combination, whether this combination already exists in the data set or not. Okay, you can see 5 and 7, that is mathematics marks is 5 and stat marks is 7. There is no student exist in this particular data set. So S10 is another one student whose marks in ML is going to be estimated. We need to estimate this, but we only have the marks of maths and only have the marks of stats. Then what is the marks of the ML? This is called the estimation. And how can we do this? So which type of model we means method uh, means a problem it is, whether it is classification or regression. You can see the marks of maths. Okay, sorry, marks of maths, our target variable. Okay, we only look at the target variable, what type of data set it is. Okay, so look for the target variable, that is what type of data set, whether it is the marks is means the data set is continuous or it is discrete or categorical. You can see it is not a categorical data. Marks is not a categorical data, right? So so it is not categorical, and we also do not know that under means the range, which range this student may also have 5.6 or 5.5, or some any fractional marks also may have this one. Okay, or some other marks we don't know, means so what is this? It is not, there is no particular category exists here in case of marks. Understood? So this is, of course it is continuous. Marks, weight, height, this kind of things are, of course it is continuous, and we need to use regression. Okay, so now what is regression? There are statistically, if we means since you are the student of aerospace, so we need to build scenes, and also we are going to make the optimal uh, means design of the aircraft. So that is why we have to use the statistical method of regression. So statistically, two types of regression analysis exists. One is called linear regression, another one is called nonlinear regression. Okay, so it is it depends on us that what type of regression we will apply. Okay, we can also apply linear regression. We can also construct the model based on linear regression, and also we can construct the model based on the nonlinear regression or some nonlinear model. Okay, so basically we need to check that which model fits better. Understood? So this is how we have to means estimate the data, estimate the target variable based on the other uh, independent variables. Means what are the values of other independent variables? Based on that, what should be the value of the target variable? We have to estimate that. Okay, So linear regression are of two types: linear and non-linear. Okay, so linear regression also based on the number of independent variables. Okay, this both linear and non-linear. There are also they are of two types. One is called simple linear regression and multilinear. Similarly, nonlinear also has two categories. Okay, so simple nonlinear and multivariable or multi nonlinear. So it is basically based on the how many based on the number of variables, number of independent variables. Okay, now go for the previous data set where the marks of mathematics, marks of statistics, and marks of ML are there. So we need to check that means we are not looking at the target variable right now. We're looking at the independent variables now. So how many independent variables are present? So x and y, two independent variables. So if the number of independent variable is more than one, then it is called multilinear or multi nonlinear. It is falling under the category of multi. Okay, if the independent variable number of independent variable is only one, then it is simple linear regression. Okay, so one independent variable, simple linear regression, or linear or non-linear. Okay, simple linear or non-linear, and more than one independent variables, multi linear or non-linear. Okay, so this is the type means so what is our target based on means basically in aerospace dataset it is a multiple type of datasets, means many factors are there, many independent variables present. So we will be focusing on multilinear and multi nonlinear model here. Okay, okay, any doubt up to this point? Please explain, please you can ask me in the chat box, or you can unmute yourself and you can ask me also. Any doubt? Okay, so I suppose that it is clear for all of you, clear to all of you. Now I'm going for the next stage. Okay, how the method, now I'm going deep into the method. Okay, so first I will show you how linear regression work, and then I'm going to show you how nonlinear regression works. Okay, first I'm starting with the simple linear and nonlinear regression, and then I will go for the multi cases. So for linear regression, simple linear regression, now how models are created and what should be our target based on the aerospace or aircraft data set. Okay, we need to explain that. Okay, simple linear regression. So simple linear regression, let us first consider only one independent variable is there and one dependent variable. Okay, I'm just giving you an example. So I'm just means considering x and y. So y is the target variable or dependent variable, and x is independent. Okay. Okay, now the data set, let us suppose it is 1, 2, 3, 4, 5. Okay, and the y target variable, it is, let us suppose it is 2, 4, 3, 6, 8. Okay, and so on. So what or how we can make the model? Look at this independent variable axis, it should be on the horizontal plane or horizontal line. Dependent variable should be on the vertical line, and this is just plotting the points and nothing else. So 1 2, this is 1 2. First point, there is x is 1 and y is 2. So just we need to plot the point 1 2 here on the xy plane. So it is suppose 1 2 3 4 and so on. It is 1 2. So this is, let us suppose, 1 2 point. Okay, 2 4, this is 2 4 point. 3 3, it is 3 3 point. 4 6, it is 2 4, it is 3 3. And the next point is 4 6, it is 4 the 3 4 5 6, 4 6 point. And the last one is 5 8, so 5 8 points like this. Okay, so we need to, now we are targeting what? Simple linear regression. So these are the points you can see, and we need to draw a line. Since it is linear regression, linear means a straight line, so we need to draw a best fit straight line. So best fit means it is not necessary that all the points must lie on the straight line. No. Okay, it is like that. It should be, there should be a balance between the number of points on the upper side and lower side of the straight lines. Okay, it should be like this, like this one. Some points may be on the straight line, some points may be upper side of the straight line, and some points may be the lower side of the straight line, but there should be a balance between them, all of them. Okay, so this line is called the best fit line, and which is the, and since it is a straight line. Okay, so how estimation is happening? Since it is straight line, we have a straight line equation, which is y equal to some function of x. Okay, so in model we need to create this kind of function. Okay, so this is y equal to mx plus c type of model. Since y equal to mx plus c, we know that this is the equation of a straight line. Okay, so we need to find out what is the value of n, m, and what is the value of c. This is our main target of this modeling. Okay, if we find this model, this will be the optimal model or the best fit model for this particular data set. Okay, so this is called simple linear regression. So this is y dependent, so our target variable dependent, and this is equal to m into, m is any constant, the independent variable, plus c. C is another constant. These constant values we have to identify. If we identify this M and C, then our optimal model or our best fit model, we can have it, and we use this model to find out the value of Y for any value of the independent variable. Okay, so now let us suppose based on these points we are getting the line as Y equal to 2x plus 3. I don't know whether it will come or not. I'm just giving you an example. Okay, let us suppose this one. Okay, so since it is 2x plus 3, now the student, let us suppose if the x value is 10, then what should be the value of y, that is the target variable. So we simply put 10 here, x. So it is 2 into 10 plus 3, 23. So for value 10, the value here, y value should be 23. So this is the estimation of simple linear regression. Now, what is simple nonlinear regression? So in case of simple nonlinear regression, we will not plot the straight line. We have to plot any other curve. So any other curve means that may be uh, parabola, not parabola. It is any polynomial, or it may be any logarithmic curve, or any exponential curve, or inverse curve. Okay, so these kinds of different types of curves are there. So any curve we can use. There is no fixed method, and you need to choose here. If I say polynomial has different degree: polynomial of degree 2, polynomial of degree 3, polynomial of degree 4, degree 5, and so on. Better if you are fitting the nonlinear polynomial curve, then it is better just stick on the degree 2. Do not go for 3 or 4, otherwise the chances of error becomes higher. Okay, logarithmic curve, any logarithmic curve is log of, okay, a plus bx type of curve you can also fit. Okay, or a into log x or log bx, this type of curve also you can fit. Exponential curve, a into e raised to the power mx. So we need to find out the value of a and m. Here we need to find the value of a and b. Here also a and b. Inverse function, so it is 1 by, or just it is like this, x to the power minus a. You have to find the value of a, or b into x to the power minus a. You have to find the value of b and a both. There are numerous type of, okay, curves exist, nonlinear curves exist. Okay, and you need to it is totally based on you. Okay, you are fitting what kind of curve you are fitting, totally based on you. You need to the design curve, there is a governing curve. You have to identify that is, yes, I want this kind of curve. So you need to, let us suppose polynomial. I want polynomial curve like this: y equal to ax square. Then you need to fit the x square. I want polynomial like a x square plus bx plus c. This kind of polynomial curve you can also fit. Okay, I want a cubic curve, y equal to ax cube plus bx plus c, or bx square plus cx plus d, like this. This is a cubic curve. So it is the choice based on your choice. So here you can see, here you need to estimate a, b, c, and d, four unknowns. Here you need to estimate a, b, and c, three unknowns. So everything, by programming everything, you can easily find it out. Okay, now I'm going to give you an example. of real aerospace data. Okay, before that, uh, are you having any question or any doubt? So please ask me. Okay, I'm giving you just 1 minute to this for any question or answer session. So any doubt, please ask me in the chat box, or you can unmute yourself and you can ask me. Any doubt? Clear for everybody? Can I go to the next part now? Okay, I'm getting the reply from only one. What about the others? Please, otherwise I cannot feel whether you're listening or not. It should be an interactive session. It will be both profitable for you and me both. So if you're having any doubt, any question, please ask me. Okay, so let's go to the next part now. Now I'm sharing the data set of the aerospace data, so you can see this one first. Screen visible to all of you? Okay. So I think this one is visible to all of you. This is a data set of aerospace engineering, and you can see there are different serial numbers are there. The first column, that is column B, starting for here, and this is wide body data set, and it is up to A22. The wide body data set, first column, it is representing the serial number, you can see. So A1 to A22, 22 data are there. Manufacturer, the second column is the manufacturer. So you can see there are manufacturer Airbus, Boeing, okay, Dog, McDon, okay, and Lockheed. So different types of means companies are there. The names are written here. Manufacturer type also there, A300, A310, A330, and so on. Model 600R, 200, 900, and 300, and different models are given here. Okay, diameter, so it is medium wide bodied jets, small wide bodied jets, large wide bodied. So different diameters are there. Now come here, and it is, we are seeing it is a length. Okay, so different lengths are given. Then next column is the fitness ratio. Next one is area, span, aspect ratio, length to span ratio. Okay, 1 by 4 squat ratio, MTOW. Okay, and there are max T by O. Okay, and max payload. Okay, fuel mass. Okay, max fuel capacity, I think it is. Payload mass, maximum seats, maximum wing load, thrust by weight ratio. Okay, all the things are given here. Now, very interestingly, you can see, you can carefully watch the data set. Not all data are continuous, not all data are categorical also. Some data or some columns you can see they are categorical, some columns you can see they are continuous. So which columns are categorical here? You can see manufacturer, it is a categorical because some number of categories are given here, either Airbus or Boeing, okay, or Lockheed, and so on. So three or four different company names are written here, right? So this is categorical. Type also it is categorical. You can see different types are a limited number of types are also there. Model also we can consider it as a categorical data. Okay, diameter also you can see, as according to this data set, diameter no particular value is given, only the medium wide bodied or small wide bodied or large wide bodied. So this kind of uh, names are written here, so we can also consider this one as categorical. Okay, now come to the length. This is not categorical, different lengths are given, so this is continuous. Fitness ratio continuous, all other next up to next all other data set they are continuous data. You can see MTOW also continuous, this is continuous, continuous, continuous. Now everything is continuous. Understood? So I think these are very interesting, and data sets is given here. So mixture of data, continuous and categorical. But whether you will apply the regression or whether you will apply the classification. What is your application? Means which method you apply here, regression or classification. It will be based on what you are targeting. So according to your target data set. Now what you are targeting? Are you targeting the length, that is your dependent variable? Is it length? Is it diameter? Is it model? Is it manufacturer? Based on that, it should be you have to apply the classifier models, or you have to apply regression. I think you are understanding this now. So manufacturer, if you are targeting the manufacturer, you can see there are only two or three manufacturers are written. So Airbus, okay, Boeing, okay, and Lockheed. So these kinds of things. So three or four categories. So if we are targeting, or our outcome variable is manufacturer, if we consider, okay, we are only considering we are estimating the company. If this is the length, this is the fitness ratio, this is the area, span, and this kind of data sets are given, so identify the name of the company. So for name of the, so different, these different types of independent variable values are given to you. Okay, and you need to identify the company name. So if you are going to identify the company name, of course it is a categorical data, categorical outcome will be there. And for that, you need to apply the classification. So your model should be in classification category. Okay. But let us suppose our outcome variable is MTOW. This is our outcome. So if for all other variables, manufacturer, type, model, diameter, length, okay, these values are given, you need to identify what is the MTOW. Okay, then it will be a regression. Now, what type of regression you can apply here? So generally, either we should go for the MTOW, minimization of MTOW, or we need to yes, fuel consumption. And I think this is the last one is the other one, fuel consumption. If we are considering the fuel consumption, so fuel consumption also we need to minimize this. Okay, so fuel consumption must be minimized because to build a sustainable aircraft which is sustainable for the environment sustainability. So fuel consumption we need to minimize. Okay, if we are targeting for speed or something, let us suppose speed, I think the speed is not there. MTOW, let us suppose. MTOW, I think it is the total weight of the aircraft, it is something defines. So also we need to minimize it because we should not get a very overloaded aircraft. Okay, so in that case, these are the things we need to optimize it or minimize this one. And this is continuous data set, so we have to apply the regression. Understood? Now, how we apply? So if we apply the regression here, if we apply the regression, whether we need to apply the multi-regression or linear regression or simple regression, which regression we need to apply here, multi or simple? Of course it is multi, because if we consider the MTOW only as a dependent variable, all other variables are independent. So length, fineness ratio, area, span, aspect ratio, okay, length to span ratio, 1 by 4 chord and other, all these variables, these are, so number of multiple independent variables are there. So of course we need to apply multi-regression here. Now what kind of multi-regression? Multilinear or multi-nonlinear? This is the main question. Okay, it entirely depends on means the problem data set. It entirely depends on means your idea also. Okay, and basically multi or linear we need to apply, we need to apply, or we need to identify based on the error coefficients also. Okay, that is, we first need to apply the linear regression first. We are getting some model based on that. Okay, now we check the errors. Now again we form some nonlinear model. After forming the nonlinear model, also we need to test the data set. Again we check for the errors. So if the error parameters, these error values are more for nonlinear, then of course we need to means collect the linear one. We need to go for the linear. And if the error for the linear is less and nonlinear is sorry, linear is more and nonlinear is less, of course we have to go for the nonlinear case then. Understood? Okay, any doubt? Any doubt from anybody? Okay, then now I'm going for the modeling. How to model the means data sets. Let us suppose um, these are the different parameters. Let me correct this one first. I'm considering from the length only. Okay, I'm not considering the entire data set. I'm considering from the length up to M2W, up to this. Okay, only up to this data set. Look, also there is some problem, there is some issues we can see here. Is there any value? No value is there. If we go for the data set also, many missing values you can find here. Missing value here, it is missing value here, it is missing value here. So many places are there, you can find the missing values here. The entire this particular 1 2 3 4 cells are totally vanished. Here 2 cells are, no data is there. Okay, so you can see, so this is wow, this is called, this is an uncleaned data. Okay, so what is unclean data? Where this kind of missing data can be found. So we see this data set is unclean. This is not cleaned yet. So we need to, if there is some missing values or missing data set is there, so we cannot find a model for that. We cannot go for any kind of calculation. Okay. So first we need to refill this data. And how can you do this? Either we can delete the, if the missing data is very less, only one missing data is there, or two or three, or in only a single row, I can say, let us say row 5, how many missing data is there? 1 2 3 4 5 6 7 8 9 10 11. Yes, 11 missing data is there in row 5, fifth row. So we can simply delete the fifth row. To just, if you delete it, then the fifth row, which is having the maximum number of, I'm talking about the row only. Okay, do not delete the column. If you delete the column, then one of the variable, independent variable, will be totally vanished from your model. Okay, so do not delete the columns, delete the row only. If you can find only a single row is having a large number of missing data set, then you can delete that one. Otherwise, if in random places, if you are saying that any random places there are many missing values, but not from the single row only, some random places you can find it. So it's here, okay, here. Okay, I think there is, this one is also okay. So if some random places missing values are there, here also you can see here, then there are a bunch of algorithms present to uh, means refill these missing values. First, either you can means fill these missing values with 0, which is not recommended at all. Okay, for this kind of data set basically. So for this kind of data set, what we can do, we can use mean or average. Okay, we need to find out the average of the entire column, and we can put the average here. Okay, we can put the average here also and here also. Okay, average of the entire column. Okay, average of the entire column we need to put here. Okay, we can also find the mean also, I discussed. We can also find the median or mode to refill these values. Okay, there are also some other algorithms are present in Python or in MATLAB or in Excel only. You can refill the data, or you can means first clean the data. This technique is called data cleaning. So if you don't clean the data, then you cannot proceed for the modeling part. Okay, so first your task is to clean the data. So now I'm going for the modeling part here. Now let us suppose I am using the method of mean, and method of mean, if you apply, you can see here it is 260. What is the sum of this? Just if you calculate this one as a 260, 219, I'm just roughly I'm doing this 290, sorry, 219, sorry, 363, again 363, 437, and 845. Okay, and how many is it? 1 2 3 4 5 6. So 414.5. So it is 414.5. Okay, so you can use this technique here to clean the data set. Okay, so now let us suppose this is our dependent variable. These are dependent variable, and all the other things, these are the independent variables. Okay, so how can you do this? So how can you clear, so how can you make the model first? The model can be created like this. If you are going for the linear, of course you can see these are the multilinear, because this is x1. Let us suppose x1 is the length. I'm just symbolizing this one. Fineness ratio x2, area x3, span x4, aspect ratio x5, length to span x6, chord x7, and this is y. Y is the dependent variable. Okay, so how can you make the model now? So after the means after applying the method, our linear model will be like this. Y is equal to some constant a plus let us suppose it is a0, a1 into x1 plus a2 x2 plus a3 x3 plus a4 x4 plus a5 x5 plus a6 x6 plus a7 x7. Sorry, x7. Got it? So this should be our model here for linear case. Okay, to identify the values of a0, a1, a2, a3, a4, a5, a6, and a7 based on this particular data set. Okay, so a0, a1, a2, let us suppose different values are there. Let us suppose it is 214 point something, it is 321 point something, it is 333 point something, it is not it is very larger, 320.56, and so on. Okay, so this should be our best fit model. And also after finding the model, okay, we need to test the model to identify the MSE. This is a error analysis. MSE means mean square error, and root mean square error, RMSE. Okay, these two values is basically identified to check that whether our model, how much fit it is, how the error quantity it is. And another matrix is also there, which is called the R square value. Okay, the value of R square should be in between 0 and 1. Okay, as compared to means as it is In case of linear, if it is very much close to 1, r square value is very much close to 1, we can say that yes, our model is it fits the most. Okay, now in case of non-linear, so how non-linear model is created? Okay, a non-linear model, I told you that non-linear model, there is no fixed model of non-linearity. Okay, so we can, if we choose to build the nonlinear model like as a polynomial of degree 2, then how we can create the model? Okay, we can create the model like this. Let us suppose a0 plus a1 x1 square plus a2 x2 square plus a3 x3 square plus dot dot dot. Okay, plus uh, b1 x1 x2 plus b2 x2 x3 plus b3 x1 x3 plus b4 x1 x4 and so on, and whatever the combinations are there, x1 x2 x2 x3 x3 x4, whatever the combinations are there. Okay, so we have to apply all the combinations up to this. This is also a polynomial of degree 2. So for the sake of simplicity, sometimes what we can do, we do not consider these values at all. We only consider the squares, the xt square up to a7 x7 square. So this kind of model we consider. Also we can consider plus okay, b1 x1 x2 with this. So that will be more generalized model, generalized polynomial of degree 2. Okay, if you are going for the logarithmic model, you can consider it like this: a0 plus a1 log x1 plus a2 log x2 plus a3 log x3 plus a4 log x4 plus and so on, plus a7 log x7. You can consider this model for polynomial. Okay, and in case of linear case, you identified a0 a1 a2. Here also you need to identify a0 a1 a2 a3 a7 like this. Here also a0 a1 a2 like this. Okay, so it totally depends on you what kind of nonlinear model you will fit. It depends on you. Okay, if you are having any doubt or problem, then please share. Regression analysis, you can use MATLAB, you can use Python. Okay, you can use any kind of tool. There is no restriction for that. Okay, I will also show you how to build the model in MATLAB or in Python. Okay, so if you are having MATLAB, then better to use MATLAB if you are having it. Okay, some means type of already inbuilt function is there in MATLAB, so you can use them. But today it is, since the theoretical part I need to discuss, so that the idea and the base of the nonlinear and linear model, what is linear and what is nonlinear, it should be clear. Otherwise, you can't understand. After finding the model, you can't understand that is what to do and how it came and whatever the other things are there. Are you having any doubt? Are you having any doubt? You can ask me in the chat box. No, we are not taking the values of A. The values of A0, A1, A2, A3 should automatically be calculated. Means that is the model. Means we need to identify the values of A0, A1, A2, A3. Okay, mathematically. We need to find the values. We will not consider the values. This is the main part of the regression. We don't consider this one. We need to identify these values A0, A1, A2 and other. Okay, these values we have to identify. Means find, basically we need to find it. We are not putting the values of A0 or A1 randomly. Okay, the model means after the methods, the methods is, it is called least square approximation. Least square approximation method, there is a method is there. Okay, by applying this method, okay, the A1, A0, A2, all these values automatically will be means we can find it. Model will means the mathematics will give us just to solve it, like that. Understood? Any other question? Okay, next day when we are going for the programming part, okay, then it will be clear to you it is how the model is created and how the values of A0, A1, A2 and all the others means these coefficient values are identified. Okay, model will give you the values. Means after the solution, the values you have to find it and then you need to put the values into the model and the model is created. And then we need to optimize our optimal design of the aircraft. Any other doubt? Okay, yeah, no doubt. Then, so before ending this session, I need to means clarify another thing that there are many statistical aspects behind this regression analysis. Okay, and then it's auto correlation. Some things you need to check before starting the before evaluating the model. Okay, so the data set, that is all independent variables. Okay, there should not be any autocorrelation. It means that independent variables are independent, should be independent. Okay, there should not be any kind of proper relationship between the independent variables. Otherwise, we cannot get the proper model. Okay, next one is correlation coefficient. So I ask all the students to please means just a little bit you can Google it or you can search for what is a correlation coefficient. It is also a very important metrics to identify whether there is any relation exists between any kind of independent variables or not. Okay, we can check it from correlation coefficient. Okay, if you know this the correlation, then it is okay. If you do not know what is correlation, you can just Google it, or there are many internet resources which is available. Okay, you can read or you can watch any video for correlation coefficient. Okay, then on the next class I will explain uh, how by using MATLAB or any other programming software you can find the model, both linear and non-linear. Okay, so I think Nobody has any other query. So I'm going to winding up the session now. Thank you for attending the session, and good night all.